Hello everyone, this is Devi. This session is about two important components of physics, which is nothing but diode and transistor. But we are going to learn the difference between diode and transistors. First, let me explain what is diode. To explain a diode in a simple way, a diode is a semiconductor device that essentially acts as a one-way switch for current. It allows current to flow easily in one direction but severely restricts current from flowing in the opposite directions. Let's learn about the importance of diode. Diodes plays a crucial role in electronic circuits. They primarily serve two key functions, rectification and signal modulation. In rectification, diodes convert alternating current, which means AC current, to direct current, DC current, essential for powering electric devices. Additionally, diodes are vital for signal modulation in semiconductor devices, enabling precise control of electrical signals in various applications including communication systems and information processes. Next, what is transistor? A transistor is a semiconductor device that acts as an amplifier, switch or signal modulator in electronic circuit. It consists of three layers of semiconductor material, the emitter, base and collectors. Importance of transistors. The first one is amplification. Transistors amplify electrical signals, enabling weak signals to be strengthened for various applications. Next one is switching. Switching functions as electronic switches, allowing or blocking the flow of current. Next one is signal modulation. Transistors are used for modulating signals, altering for transmission or processing. Voltage regulation in transistor. Transistors can be used for voltage regulations in electronic circuits. One common type of voltage regulation circuit involving in transistors is the series voltage regulation. Let's learn about types of diode. There are various types of diode like light emitting diode, laser diode, Zener diode and p-n junction diode, but we are going to discuss about the three different characteristics of diode. The first thing we are going to learn about is forward bias diode. Forward bias or biasing is where the external voltage is delivered across the p-n junction diode. In a forward bias step up, the P side of the diode is attached to the positive terminal and N side is fixed to the negative side of the battery. Here, the applied voltage is opposite to the junction barrier potential. The next topic is about reverse bias diode. When we apply the external voltage across the semiconductor diode in such a way that the positive terminal of the battery is connected to its N side and the negative terminal of the battery is connected to the P side of the diode, then it is said to be in the condition of reverse bias. The last one is zero biased diode. A zero biased diode refers to a diode that operates without an external voltage bias applied to it. In this state, it functions based on the neutral properties of the material it's made from. It's also called as unbiased or self-biased diode. Now let's see about the types of transistors. There are many types of transistors like bipolar junction transistor, diffusion transistor, avalanche transistor, Schottky transistor, multiple emitter transistor and so on. Let's see about the three main types of transistor. Transistors are divided into three types. Bipolar transistors, BJT, bipolar junction transistor, FET, field effect transistor and insulated gate bipolar transistor. A bipolar transistor is a type of transistor that uses both electrons and holes as charge carriers. And lastly, transistor symbol. Does the transistor have symbol? Yes. The transistor symbol consists of three layers, the emitter, base and collector. It typically looks like two diodes arranged back to back. The arrow points in the direction of conventional current flow from the positive side of the power supply to the negative side. The emitter is where current enters, the collector is where it exists, and the base controls the current flow. The transistor serves as a crucial component in electronic circuits, amplifying or switching the signals. The last but not least, how transistors and diodes are working together. Now, combining the transistors and diodes together. Diodes are often used to protect transistors by preventing reverse voltage from damaging them. Transistors can use diodes in their biasing circuits to ensure proper forward biasing for the transistors to function as intended. Example, diode in transistor. Placing a diode in parallel with the collector and emitter of a transistor can protect the transistor from reverse voltage. The diode conducts when reverse voltage is applied, diverting the potential damaging current away from the transistors. The combination of transistors and diodes in circuits allows for signal amplification, switching, and protection. Diodes are often used to control and protect the flow of current within the transistor circuits.